Everyone, my name is Bernadette Costa Tempestad. I am originally from South Africa, from the stormy coast. From there, the name. I am currently living in CAID, in the farthest reaches of CAID. I am in Sarkatan, which is Las Vegas. And yes, it is deadly warm here right now. We are today talking about learning how to do some geometry drafting. This is a class that you can actually take part in. So if you have some paper, straight edge, and compass ready, then you can definitely follow along and draw along. Hopefully it goes slow enough that you can practice. If you don't and you're just here to see how it's done, the video will be up afterwards and you can always go back and relearn all the different steps. You can also drop me a line and with your email, and I will make sure that I send you the actual presentation, because if you're anything like me, I like to have slides and be able to click through them at the speed that I work at. And we can definitely set that up for you as well. But to start with, we are going to just listen to me do the video, which is very weird because we just don't hear ourselves speak often enough. The video is about half an hour long, so we will have plenty of time afterwards to ask questions. If you do get lost somewhere along the way or have questions along the way, then we can totally stop the video and go back or check and see where people are lost.
Hello all, today we're talking about geometry with a straight edge and compass. We are going to learn the basics about dividing an angle and then circles. A few short notes: all the images are either from Wikipedia or I took them myself. English is not my first language, so please excuse any bad pronunciation. Many design elements and elements of buildings will have different names, and I might not be using the most current one. Please bear with me. My focus is mainly on architecture and tiles, but tessellations can also, of course, be found in any design, anything that uses design: calligraphy, fabrics, embroidery, pottery, carpet. In fact, almost all decorative forms. Islamic art can generally be divided into three major categories: arabesque, calligraphy, and tessellations. Arabesque is, of course, intertwined flowers and vine. They can be totally free form or they can be set to a grid. Often you find a combination where there's an underlying grid with free form flowers and vine. Calligraphy is, of course, the written text used as a design element. But today we're talking about tessellations. Tessellations at first glance is extremely complex, but most of them are based on very easy design elements which are then repeated. As you can see here, we have the design elements repeated on a regular grid. So what do we need? We need a straight edge. I specifically say straight edge and not ruler, because a ruler implies that it's divided into regular sections, usually centimeters and inches. We do not need that. We just need something that you can use to draw a straight line. Then we need a compass. In period, compasses would have had two sharp points, and you would have used the one point to scour. These days, we make it easier on ourselves, and we have a sharp point and a writing point. The example on the left is a simple school compass. They are good to start with. However, if you get into this a little bit, you're going to want to invest in something a bit more like the one on the right, because the one on the left opens and closes too easily. It means that it will open and close while you are drawing. The more expensive compass will give you much better accuracy, because if you open it to a certain size, it will stay that size. So we are going to start it by, the first thing we're going to learn to do is to divide an angle in two. This is the most important skill that you're going to have to learn to be able to do tessellations. So we're going to take some paper and on it just draw some random angles. You will see that at the intersection of my angles, I don't just have the lines come together, I actually overlap them. That is because, especially with more acute angles, it's much easier to judge where the actual intersection is when you have the overlap. So now we take out our compass and we put the sharp pointy edge on the intersection of our first angle, and we open it up a little bit and we draw along the leg of the angle a short arc. Now in theory you could just draw a big arc across the entire angle. However, once you get into more complex tessellations, you're going to have a lot of lines on the paper. So it's better to get into the habit of drawing as small as possible construction lines to help you with confusion later on. So we draw short arcs on each of the legs of the angles without changing the opening of our compass. Then we move our compass so that the sharp point is on that new intersection you formed on the leg of the angle with the short arc, and you draw a new short arc about halfway between where the legs of the angles are. If you don't get it right the first time, not a problem. You can just draw arc, and if they don't intersect, you can just go back and draw a new one. As long as you don't change the opening of your compass. So you're going to use your compass first on the one leg, draw a short arc, then on the other leg, draw another arc and make sure the two intersect. Final step, you just draw a line through the new arcs that you created and the original intersection of your angle. Your angle has now been divided into two equal parts. Easy, isn't it? Well done, you have just mastered the most important skill of doing tessellations. You are going to use the skill over and over again. Part 2, dividing a circle into 4 and then 8 equal sections. A circle divided into 4 and 8 is the basis for the vast majority of tessellations. When we have a circle divided into 8, we actually can form 3 different type of 8-pointed stars. We're going to start with the most basic one as shown here, which is called the basic 8-pointed star, and it has these short, stubby little rays. So to start, we have to draw a circle. I always advise that before you draw a circle, you mark where the center of the circle is going to be. And that is because I have spent way too much time trying to find the minute little puncture where I had put the sharp point of my compass. So draw a little X, and then open up your compass. People always ask me, how big? It doesn't matter. It very much depend on where you want to go with your design. Since we don't at this point know where we're going to go with our design, let's just make it easy and say we open up our circle at about 2.5 inches. So we open up our compass about 2.5 inches and draw a circle, starting with a little X at the center. Then we draw a line that goes through the center of the circle and intersects both sides of the circle. Now we have to divide that line up, and that's actually very, very easy. We are dividing an angle. The angle happened to be totally flat, but the principle is the same. We start by pointing our sharp edge of our compass at 12 o'clock. Now, of course, I forgot something. we want to work outside the circle. That is because as we get to more detailed tessellations, we're just going to add more and more lines, and we don't want to add confusion by having construction lines in our working space. So we open up our compass a little bit, maybe about 4.5 centimeters. Now we put the sharp end of our compass at 12 o'clock, and we draw a short arc about where 3 o'clock is. Then we put the sharp point of our compass at 6 o'clock, and we draw a short little arc about at 3 o'clock so that the two arcs intersect each other. And then, of course, we just draw a line straight through the center of our circle, and our circle has been divided into 4 equal parts. This is step 1. Once we have our circle divided into however many equal parts we want, it still doesn't give us the shapes that we want. To get the shapes that we want, we generally want to draw lines that connect the intersections along the curve of the circle. So for this one, we're just going to connect up each of the intersections along the curve of the circle. And that, of course, is going to give us a square within the circle. Each of the intersections are just connected to each other. This is the first stage for a lot of designs. Now we want to move on. And of course, if you look at this, you see that the design doesn't have 4 points, it has 8 points. So how do we get from 4 points to 8 points? Consider it for a moment. You know exactly what to do. Yes, all that we're going to do is we are going to divide the angle into 2 equal parts. And we have the skills to do that. We are going to put our the sharp point of our compass at 12 o'clock, and then draw an arc at about 1:30. And then put the sharp point of our compass at 3 o'clock and draw an arc back at about 1:30 to intersect the previous one. Then we're doing it on the bottom again. We draw put the sharp point of our compass at 3 o'clock, draw arc at about 4:30, sharp point at 6 o'clock, arc back at 4:30, intersecting the previous one. And then we draw 2 lines through the center of our circle. Now, a lot of people instinctively want to do it 4 times, but as long as you go through the center of the circle, the opposite side is actually going to be divided as well. So now, once again, we need to connect the intersections along the curve of the circle. So the reason I did this is to make it all easier for you, because 4 of the intersection is already used, so you're not going to feel like you need to use them again. Instead, what we're just going to do is connect up the 4 open intersections that it hasn't been connected up with anything else before yet. So that will give us 2 squares within our circle, one slightly tilted from the other one. In fact, it's tilted by 45 degrees if you're into that type of stuff. And there you have it, our first basic 8-pointed star. Now you're looking at it going, where? There you are. All you have to do is highlight your lines a little bit, and you can very clearly see our basic 8-pointed star with its short, stubby little rays. I promised you 3 types of 8-pointed stars, so let's move on to the second one. 2 of these examples, the ones on the left, actually have the second type of 8-pointed star as part of their design. So usually in my in-person class, I would tell everybody, okay, we're going to redo all the steps and divide the circle into 8 again, because practice makes perfect. However, we don't want to sit here with 5 minutes of dead time. So if you're doing this class by yourself, just hit pause, open your compass at 2 centimeters and divide your circle into 8 equal parts. If you are, if I'm running this, then take your previous piece of paper and just connect or extend out the lines of your previous star. As you extend out the lines of your star, you will see that they intersect with each other. So they will intersect further out. And these lines that are further out, that intersect further out, will actually forms a new 8-pointed star. And here we have it, the new 8-pointed star. This 8-pointed star actually have an angle of 90 degrees between each of the rays of the star. And many people believe that's why, but maybe it's just because of the way it looks that it is called the seal of the prophet. The Moroccan mosaic tile artisans actually have a very specific name for the star just because it is used so commonly with mosaic tile designs. And if you overlay the new 8-pointed star over our basic 8-pointed stars with its short, stubby little rays, you can see clearly that is a very common design that we find in tile designs, and in fact in many other designs. It gives us our basic 8-pointed stars and then these arrow-like protrusions of them to form our seal of the prophet star. Okay, now we're straight onto the third way of doing an 8-pointed star, and we're starting all over again. Make your cross, draw your circle. Once you've drawn your circle, do your little arc, do at 3 o'clock, another little arc at 3 o'clock, draw your 4-point intersect. However, do not draw the square within the circle. We just want to get the intersect. So the next stop is we draw the 8 intersects. So we have 8 pie pieces. We divide each of the 4 pieces in half by doing our 130 and 430 little arcs and drawing our line between the 2. Starting to become easy. Now I'm going to teach you a little formula. What we're drawing is called a self-intersecting octagon. You can actually draw this without picking up your pencil by just ending your lines right at the circle. However, as I've told you, I'm not a big fan of that, so mine intersects the edge of the circle. However, if you were to just not pick up your pencil, you could draw this whole thing in as one movement. So we're going to start and we're going to learn our new formula. Our new formula says start, skip to, end. We're talking about where the rays of the divisions intersect the curve of the circle. So if we start at 12 o'clock, we skip 1:30, we skip 3 o'clock, and we end at 4:30. So start, skip to, end. Now we're going to start where we ended. So we're going to continue on from the same point where we ended. Where we ended, we're going to start. So 4:30 start, skip to, skip 6 o'clock, skip the next one, and end at 9 o'clock. start, skip to, end. Now this is going to look very crazy, but in fact, just stick to your formula and your end result is going to be this. So remember the formula: start, skip to, end, start, skip to, end, start, skip to, end. And you'll find that you won't be reusing any of the intersections. You will just work your way around a few times and end up with this star, a self-intersecting octagon. Okay, let's do something really exciting. Let's get adventurous. I'm just joking. Even for me, this would take days to figure out. I just wanted to show here that all of these stars, and it's often easier to count the rays rather than the stars, but all of these stars are 8 and 16 point intersections. So the basis for this design is 8 and 16 point divisions of a circle. Part 3, dividing a circle into 6 equal parts. If you look at this design, you will see right in the center, we have our basic 8-pointed star. But if you look at the 4 stars surrounding the center, you will see that they actually have 6 rays. That is our next design. A lot of designs are touted as being divided into 100. They actually aren't. They generally are divided into 96 equal parts, which, if you can do the math, you'll find is very easy to do once you divide a circle into 6. So with this design, we have our 8-pointed star, we have our 6-pointed stars, and in fact, the negative spaces then also means we end up with 4-pointed stars. Now, if you thought 8-pointed stars were easy, 6-pointed stars is going to blow your mind. So once again, we start by drawing a circle. Remember the little X in the center. Then we mark anywhere, somewhere along the curve of our circle, just a spot, just a little line to mark a spot along the curve of our circle without changing this how far the compass is open. Just keep it the exact same size as what you use to draw the circle. Start by putting your compass on the new mark that you draw along the curve of the circle and draw yet another arc. Then you continue this all the way around the circle. So where the previous one's finished, you put your sharp point on that intersection and draw the next intersection along the curve. Move it on, draw the next intersection, and you should find that the final intersection falls right on top of the first intersection. Easy, isn't it? Now, instead of drawing squares, we draw triangles. So the formula is start, skip 1, end. Start, skip 1, end. And then we have the first triangle, and then we use the 3 that wasn't used before to form our second triangle inside our circle. And this, of course, gives us a hexagram or a Star of David, a very familiar design element across all cultures. And all of you that do a lot of designs have a compass near you, and you can always divide that circle into thirds that seem to always happen in designs. So if you look at this at first glance, you're like, wait, there's no star. However, when you look at the top left-hand corner, you will see that there's actually 3 rays of a star. That means it's a quarter of 12 points. This tile would have been laid as 4 different tiles that's turned each time, so that you have as the center of your design a 12-pointed star, and then you have this very beautiful interlaced designs going around it. Part 4, dividing a circle into 5. Now this one, I have to admit, is much more challenging. In fact, every time I have to divide a circle into 5, I pull out my little printed out piece of paper and I follow the steps, because I just don't do it often enough. It is just not as common as the other ones in the different designs. You can find designs that has that was divided into 5, but they are fairly rare. So like I said, even when I have to do this, I have to pull out my trusty piece of paper and just quickly learn up the steps again. So my trusty piece of paper come from Crayola teachers. They're happy for you to use their piece of paper in a class, which is what I am doing now. So to divide into 4, we start and we draw our circle, and then we draw our line through the center of the circle. They have called it AB. Then we divide AB with another line called CD that divides our circle into 4. You can see that they actually draw little arcs at the top and the bottom. That's not how I taught you. But it doesn't make a difference. After a while, you get into your own rhythm. I do as little work as possible. So we put it on our intersections on A, B, draw arc C, and D, draw a line through the center, or just do C and then draw a line through the center. Our next step, we want to make our radius of our the same as our radius of our original circle. So what you're going to do is you're going to put your pencil with the sharp point in the center of the circle, and then you're going to open it up so that it falls right on top of where you drew the pencil again. Sorry, right on top of where you drew the circle originally, so that the opening is the exact same size as what it was when you drew your first circle. Now what we're going to do is the same thing that we did when we divided into 6. We're going to put the sharp point on B, and we're going to draw a short arc at E and a short arc at F that's the same radius as our original circle. We're going to draw a line that goes through E and F. Then, now we're still manipulating that compass. We're going to put our compass at G, which is 12 o'clock, and open it so that it's the same size as where H is, where the intersection is of our line with our AB line. So we're going to very carefully open our compass to get that exact same size. Then we're going to put our sharp point at H and draw an arc through J. So we're going to put our sharp point at H and draw an arc along the AB line at J. Almost there. Last step, we're going to put our compass at G and open it so that it is the exact same size as G and J this time. Not G and H like previous time, G and J this time. And that's the size that we want. If you were being very, very accurate, you can now do the same thing that you did when you were doing the divide into 6 and just draw the 5 arcs along the curve of the circle. I always make it easier for myself, and I draw 2 circles when I start so that I can throw the one away with all the construction lines, have my second circle, and then draw the little arcs all the way around the edge of our circle. And that's it. Our circle has now been divided into 5. I would advise that you go into Crayola Teacher, you get this little piece of paper, and you follow it a few times until you are comfortable with what they're trying to describe. The descriptions are actually really good. So let's look at a few more examples. Here we have an Italian example actually, but I wanted to show something that wasn't tiles. This is a woodwork intarsia design that uses 6 and 12 pointed stars. Look at all those beautiful little 6 pointed stars. So people often ask me, now that I can do this, what do I do next? What I advise is that you find sheets like this. This is actually displayed in a museum, and this has a tile that's already been broken up. They already show you the construction that goes into making the different lines on the tile. And if you just go online and search for Islamic geometry, you will find a lot of sheets like this, a lot of examples like this that shows you how to do the geometry. And rather than looking at a tile and trying to figure out, this is a good second step, looking at somebody that's already broken it up and then trying to reproduce what they did. So here's where we end up. This is actually a dome, so it happens in 3D, and this dome actually has 5, 6, and 8 pointed stars, and of course all in 3D because it's a dome. And this was all done with geometry, without a computer, and in fact without rulers that was divided into regular segments. This is all just repeated geometry. So as you're learning, there's a lot of beautiful examples out there. If you look at the bottom of the walls here, you can see that it's a fairly simple pattern within a square, and then you have a much more complex pattern in the width of the door opening. And when you do the more complex pattern, I totally advise that you use a bigger piece of paper because it gets a bit complicated. Often when people see designs like this, they think, okay, but this wasn't based on circles. In fact, this was also based on circles. All these designs have a circle underlay, even one that looks like it's just lines and angles and doesn't look like it has any curves whatsoever. Okay, thank you for coming to my class.
And how often were 7-fold patterns used?
You know, I have, they were only used very, very late period. So we're looking at the end of the 1500s going into the 1600s. And all of the ones that I've seen have been in combinations with other ones. So it wouldn't be that the entire design is 7 pointed stars. It would be like the dome where they have all the different ones. They start with a certain number, and then because it's going bigger, you get more. They use more pointed stars. And even then, I've probably seen only like 5 or 6 examples. And I, don't want to imply I've looked at every tessellation out there, but it's extremely uncommon. It just wasn't done, but they did everything. So it is out there. And what's wonderful about this is, if any of you guys, I've more than once had math teachers in my class. If you're a math teacher, this is a great way to teach geometry for kids and actually have it be not just, oh, we're going to do this weird stuff and do all these weird calculations and stuff. This this makes it much more real for them. So yes, all the common ones are the ones. Those are the more common ones. Even the 5-pointed stars are not very, very common. We only get them for the first time in late periods, and always generally. So generally, the 5-pointed stars are done in combination with other ones as well. Definitely. Okay, and we have math teachers, so they're like, oh yeah, we know all this stuff. It is, it's, and I also very much like, the first time I encountered people actually doing this was in Morocco, with the people doing the tiling, the mosaic tiles, and literally they still use a straight edge, which is a flat, clean piece of metal, and they use a compass which doesn't have pencil bits. It has like 2 sharp points, and that's it. And then they do this extremely detailed design at the speed of light. And it's very impressive. So yeah, definitely somebody said that for illumination, there is examples in illumination, and now you're able to construct it rather than trying to trace it.
Yeah, I remember geometry class. I'm like, I can use this for art next door. But
Absolutely.
trying to prove the angle was killing me.
Yes. I learned to draft as an architectural draftsperson, like the old way, on a, you know, drafting board and stuff like that. So all of our stuff, these days, you know, the computer do all the math and stuff, but I had to learn how to do this, and never thought about it for years and years. Didn't think about it again until I visited Morocco, and I was like, oh my God, look at this.
Yeah, someone suggested a follow-up class.
Oh, yes. How to turn those stars into complex patterns. Absolutely. So strangely enough, when you see the people do this for the tiling, the next step is that you have to thicken up the lines, and they actually use like bars, like rulers, that is the right thickness that they want, and just lay them next to the line and draw the line to get the right thickness for the lines. So but there's many ways to actually do that next step, to darken up the lines if you're, to thicken up the lines if that is what you want to do, and then to make more complex patterns, for sure. And yes, maybe if you find me at an event, I'll be doing step 2. I know I do it all this time myself.
All right, any more questions? There's still about 10 minutes to the class.
And definitely go online, do a bit of a search, and now that you know the basics, it's possible to look at it and see where they're coming from, to you know, to see the this example. There's a lot of pages, like, okay, let me share that. Otherwise, it's sorry, I can see what I'm talking about. You guys can't. sorry. So definitely look at examples like this one, where you can, and there's books like this available, and a lot of just sheets like this available that that shows you what the next step are. And for a start, actually just go to the Met website, and they have some pretty basic designs as tiles, and those you can just look at it and you know, more than likely be able to figure out yourself where they're coming from, how to put them together. I do not have a good book to recommend, unfortunately. I don't actually have any of the books where this type of stuff is. I tend to just find ones I like on the online, and just have the image and work from that. So unfortunately, no good book to recommend. I know of a good book, but I don't remember what it is off the top of my head. I will find the information though and share it on the group, and so just check on the group, and I will link there a book that has many beautiful patterns. I know exactly what it is in my head now, but not where I'm going to find it quickly.